Welcome to this solution video and thank you for clicking that thumbnail. If you like this video, please share with your friends and subscribe to my channel. I'll prepare many more videos for you in future too. Question number 1 is solve the equation. This is absolute sign and it's an equality, so it becomes easy. What do? Once we write whatever is inside the absolute signs as positive, and once we write that one as negative. So 7x minus 3 will be negative, so I'll put negative in front of 4, not in front of that, otherwise it is subtract, right? So I'm writing here, so I'm changing the sign of the absolute and rest remain what they are. So we'll solve them. What do we get here? So 28x minus 12 minus 5 equals to 9. 28x equal to this negative 12, negative 5 will be negative 17, and when this goes to the other side it becomes plus 17. So it will be how much? Divided by 28, divide here by 28. So x is 26 over 28, and if we simplify this, 13 over 14. This is the first solution. What about this one? Minus 28 plus 12 minus 5 equal to 9. Minus 28 plus 7, yeah, but we'll bring it to the other side. It becomes negative 7. And I forgot to write x. Divide this by negative 28 and negative 28. X is equal to 9 minus 7 is 2 divided by negative 28. They cancel out. So x is equal to negative 1 over 14. These are the two solutions. Let's move on to the next one. Do not use a calculator in this question. They have concerned us already. So what do? We have to show each step to ensure that they know that we didn't use any calculator. Variable x and y are related by y equal to kx square, that is quadratic, right? When x is this, y is this, okay? Find the value of k, giving your answer in this format. Nothing could be that straightforward. Y, will substitute this y by this y, okay? So y is 1 minus square root 2. Kx square, so k and x square is 1 plus square root 2 square. Alright, so 1 minus square root 2 equal to, and I'll have to open this bracket and I will use this one. A plus b square is equal to a square plus b square plus 2ab. So 1 square plus square root 2 square plus 2 times a b. Okay, 1 minus square root 2 equal to k, 1, and this square root and square cancel, plus 2 square root 2. So 1 minus square root 2 is equal to 1 plus 2 is 3, 3 plus 2 square root 2, and I'm writing k later, doesn't matter. In multiplication is commutative property, you write first or last, doesn't matter. So to get rid of this, we'll have to divide here by 3 plus 2 square root 2, and here also 3 plus 2 square root 2. They cancel, so k is 1 minus square root 2 over 3 plus 2 square root 2. But we can't leave your answer like this because it's a plus b square root. See, this format we want. That means no denominator, and we'll have to rationalize the denominator to get that format. So for rationalizing, we multiply with the conjugate of the denominator. The one we want to rationalize, we write its conjugate. Conjugate is whatever is the sign in between, change that sign to other sign. So 3 minus 2 square root 2, same on top and bottom. So now another identity we will use now, a plus b, a minus b is equal to a square minus b square. This is another identity we use. If you want to multiply 1 by 1, that also will be okay, but it will take a little more time, so I will straight away use the identity. A square minus b square. Now here on top I'll multiply 1 with 3, 1 with 2 square root 2, minus square root 2 with 3, so minus 3 square root 2, minus square root 2 with this will make a positive first of all, because there are two negatives, 2 will remain 2, and square root 2 times square root 2 is complete 2. Actually it is square root 4, but we can write it square root 2. And let's complete it here. 3 plus 4 is 7. Minus 2 square root 2 minus 3 square root 2 will be minus 5 square root 2. 3 square is 9. 2 square is 4. And square root 2 square will be a complete 2 again, just like we did earlier. So it will be 7 minus 5 square root 2 over 9 minus 8, 1. Okay, there was no need to write 1, but if you want to write, it's okay. But finally, ignore it. So it will be 7 minus 5 square root 2. This is a plus b square root c format. So a is 7, b is 5, rather negative 5. Yeah, because it's positive here. Here it is negative, so negative 5. And c is complete 2, because square root c is inside square root. This is the solution. What is next? This is next. 3 points A, B and C have coordinates these respectively, given that B is the midpoint of AC. Alright, let's try to visualize. The first point is here, 2, 6, A. C is PQ and B is the midpoint of these two, which is 6, 1. Find the equation of the line that passes through C, okay, and is perpendicular to AB. Alright, that means this line, which is perpendicular to AB and passing through C. This line we have to find equation of. Give your answers in this format where A, B, C are integers. To find the equation of this blue line, we should know its gradient, but it's not possible with just one point, and that point is also unknown, right? So we need what? This is the equation of any line, y minus y1 equal to mx minus x1. We don't know gradient, we don't know points on the line, that means we'll have to find them one by one. Let's find P and Q first, okay? They are the points x1 and y1. So let's find, we know this is a midpoint, 6, 1. So we know the midpoint of AC. Midpoint of AC, which is B actually. Its coordinates will be the x1, 2 plus x2, P divided by 2 and comma 6 plus Q divided by 2. But they have already given it 6 and 1. That gives us first equation, 2 plus P divided by 2 is 6. Let's cross multiply this. 2 plus P is 12. P will be 12 minus 2, which is 10. So the P coordinate is known as 10 now. Similarly, we'll make an equation out of y coordinate. 6 plus Q divided by 2 equal to just 1. Cross multiply. 6 plus Q equal to 2. Q is 2 minus 6. So Q is minus 4. So we know the points now. They are x was 10. Y is minus 4. This is what we got. So now we have x1 and y1. What is remaining is a gradient. For gradient, let's find the gradient of AB. If I find gradient of AB, same will be the gradient of AC. Doesn't matter because it's the same line, right? And the formula for gradient is y2 minus y1 over x2 minus x1. So let's take 1 as y2. 1 minus 6 over x2, 6 minus 2, which comes out to negative 5 over 3. Negative 5 over, not 3, 6 minus 2 is 4. Negative 5 over 4. But this is the gradient of this line AB, this whole line. We want the gradient of blue line. Gradient of perpendicular to AB will be negative reciprocal of what we got here, which is positive 4 over 5. That is the gradient. Now we know this m as well. So let's find the equation now by substituting. Y is general point, so y minus y1, we got it, negative 4, equal to m, 4 over 5, we just found out, x minus x1 is 10. That's it. And to get rid of this 5, we'll cross multiply it here. So 5 times y will be 5y. 5 times positive 4 is plus 20, equal to 4 times x minus 40. So let's bring these two also to the other side because I want x to be positive. So 0 equal to 4x, 5y will become negative, plus 20, okay, this goes there, becomes negative 20. So negative 60. So let's bring this 60 to the left side again. Positive 60 equal to 4x minus 5y, but that format we can interchange their places. Final equation becomes 4x minus 5y equal to 60. A is 4, B is negative 5, and C is 60. We got what they wanted, the equation of the line. Okay, find the range of the values of x satisfying this inequality. In such, this is a quadratic, right? There are two factors which are less than 0. Always do this. First, draw a graph, and we have to find roots. Roots means this part, if it is a function, this part, if we say y equal to this, what are the positions on number line which will make it 0, right? Basically, x intercepts of this. So for roots, we will equate them equal to 0 1 by 1. 5 minus 1 equal to 0 and 6 minus x equal to 0. So this gives us 5x equal to 1, x equal to 1 over 5. Mark it somewhere. So suppose this is 1. So 1 over 5 will be somewhere here, very, very small. Okay. Now this one, 6 equal to x. So x equal to 6. Suppose it is here, 6. Okay. So let me draw it again. This is 1/5, this is 6th. These are the two roots where this quadratic graph will pass through. And because there is a positive leading coefficient, there is no negative in front, it will open up. So the graph will look like this. So in this graph, we want less than 0. Now inequality will be taken care of. While finding roots, there is no need to look at inequality, but now, where is it less than 0? And it is less than 0 in this particular y coordinate is negative in this whole area. There is no equal sign, so in our answer we will not write equal sign. So it is from x from 1/5 till 6. This is the solution, no equal sign. Here it is less than 0 in this area. Okay, what about the second part? Show that the equation, okay, something new. Equation this, show that equation this is equal to 0 where k is not negative half, has distinct real roots. Okay, whenever has a quadratic equation has distinct real root, that means the b square minus 4ac, which is also called discriminant, is greater than 0. Okay, So what is b, what is a, and what is c? This is called a, the coefficient of x square. This is b minus 4k, and 2k minus 1 is c. And we have to show that it is greater than 0. So let's do this by substituting. Minus 4k is b, right? Square minus 4 times a, 2k plus 1, c, 2k minus 1. Okay, and we have to show it, the answer will be positive. Okay, so this square is 16k square minus, okay, 4, let's leave it like this, and this is again the same identity we used in first or second question rather. A plus b equal to a square minus b square. This is the identity we used earlier. Same we'll use here. A plus b, a minus b. So it will be 2k square minus 1 square. So 16k square minus 4 times 4k square minus 1. 16k square minus 16k square plus 4. And these two cancel out. We get plus 4. Is plus greater than 0? Yes, it is greater than 0. So you can write, since discriminant b square minus 4ac is greater than 0, the said quadratic equation has two distinct real roots. All right. Next, they have given this tan graph. Okay, in the diagram shows part of the graph y equal to tan bx plus c. Okay, the graph has vertical asymptotes. You can see this, x equal to minus 4 pi and x equal to 4 pi, and passes through the points p and q. P is this 0, 3 and q is 2 pi 7. Okay, write down the period of a tan bx. Okay, so period in case of tan y equal to tan x is pi. But the question is not about y equal to tan x. Question is about this picture here. And here for period we should look at two similar points in the graph. I will take at this asymptote and this asymptote, because after that, can you see the graph shape is exactly same. It will go like this after this, something like this. So this will become the period because they are exactly at same position on each cycle. So period becomes 4 pi, this is the x coordinate of this one, the x coordinate of this one, minus 4 pi. So we subtract the lower one from the higher one, and that becomes the period. In this case it becomes 4 pi plus 4 pi, that is 8 pi. After every 8 pi the graph is repeating itself. That's what period means. This is a part. B, find the values of a, b and c. Let's start with b, because b is related with the period. B is always the full period of the original graph, which is pi, divided by the period of the given graph. This pi is fixed, but this will depend on your drawing or graph. So it becomes pi over 8 pi. So answer is 1 over 8. Okay, let's talk about C. This C. C is the axis. In this, if you see that 0, 3 is this point, correct? It means that the axis, this which was originally the x-axis was the axis of the graph, it is up for y equal to 10x. It has gone up by 3 units. So C becomes 3 because it has taken up the graph upwards 3 units. Let's talk about a. For a, these points will be helpful. Okay, so let me use the second cube. P I have already used. Y equal to a tan bx plus c. So we know most of them. Y is given here. In this point is 7. A is unknown. We want to find it. Tan b is 1 over 8 multiplied by x. In this point it is 2 pi and plus 3. Everything is known to us. Now we will try to evaluate. 2 and 8 cancel. So 7 equal to a tan pi by 4. It becomes pi by 4, right? Tan pi by 4 is 1 plus 3. So let's subtract 3 from both sides so that this 3 is taken care of. So we'll get 4 here. A times 1 is a. 7 minus 3 is 4. So we get a equal to 4, c equal to 3, and b was already equal to 1/8. All three we know now. Moving on to question number 6. The polynomial px is such that it is equal to 6x cubed plus ax squared minus 52x plus b, where a and b are integers. It is given that it is divisible by 2x minus 3 completely. That means completely, obviously. And first differentiation when x is 1 is 4. That's how we interpret this. I hope you understand this one. P prime 1 is equal to 4 means when we differentiate it for the first time and plug in x equal to 1, we get 4. That's what it means. Find the values of a. And these two situations will give us two simultaneous equations which we will solve. So let's focus on this. 2x minus 3 is a factor of the polynomial. That means if this factor is 0, the whole polynomial will be 0. And if it is 0, what does it give us x equal to? 3x equal to 3 over 2. That means if I put this 3 over 2 in that polynomial, I should get a 0. Okay, so it becomes 6 3 over 2 cube plus a 3 over 2 square minus 52 3 over 2 plus b equal to 0. 3 cube is 27. Okay, so 27 times 6 will be 162. Yeah, and 2 cube is 8. You can use calculator if you don't understand how it happened. Plus 3 square is 9 over 4a. 2 can cancel with this. We get 26 times 3 is 78. Plus b equal to 0. These denominators will create trouble, so let's multiply the whole equation by 8 so that 8 cancels out with this one. We get just 162. 8 will cancel with 4, so 2 times 9 will be 18a. There is no denominator here, that means 8 will multiply with this. So what do we get? 64, 56 plus 6, 624. Okay, plus b times 8 is 8b. Let's rearrange 18a plus 8b equal to, if I subtract 624 minus 162 will be 462, and that will be negative, but if I write it on the right side it will be positive. Okay, this is equation number 1. Let's talk about the second. They have given second information. P prime 1 is 4. So first let's find P prime x. That will differentiate the polynomial they have given. So in this one it will be 3 times 618 x square. That's what the differentiation of this will be. 2 times a is 2a, so 2ax. 52x, so it will be just 52 differentiation of this one. But, and there is b also, but b is differentiation of its constant is always 0, so there is no need to write differentiation of b equal to 0. Now p prime 1. So substitute each x by 1. So 18 times 1 square 2a times 1 minus 52. And it is equal to 4. That's what they've given here. P prime 1 is 4. So 18 times 1 is 18 plus 2a minus 52 equal to 4. Oh, there is no other variable here, so it becomes easy. 2a equal to 18 minus 52 will be minus 34, and it goes there, becomes positive 34. Divide by 2, divide by 2. So a is 38 divided by 2, which is 19. That's a. And now we have to find b. Let's put it here. 18 times 19 plus 8b equal to 462. So 18 times 9 is 162. 16 plus 342. Let's complete it here. 8b is 462 minus 342. So 8b is 120. Divide both sides by 8. Finally we get b equal to 120 divided by 8, which is 15. Got both a and b. Next part. Do not use calculator in this part of the question. Again, we have to show that everything has been done manually. Alright. Using your values of a and b, factorize the px fully. So what was the polynomial? It was 6x cubed ax squared minus 52x plus b. Let me write it here. 6x cubed plus a is 19, x squared minus 52x plus b plus 15. Okay, and we have to factorize this completely. For factorizing, we already know one of the factors, which is 2x minus 3. This will help us to factor it further. 2x minus 3. So we will divide it by one of the factors, 6x cubed, this thing, plus 19x squared minus 52x plus 15. This will also confirm if our answers are correct. A equal to 19, b equal to 15 are correct or not. So 2x, I want to make it 6x cubed, so I need 3x squared. 6x cubed, but I have to multiply with minus 3 also. That becomes 3x squared minus 3 minus 9x squared. Okay, this becomes negative, this becomes positive, cancel out. So 19 plus 9, 28x squared minus 52x. I'm bringing the next one without changing the sign. Okay, now I need 28, not 28, 14. 14x times 2x will be 28x squared. That is the purpose always. This should be exactly same. 14 times 3 is 42 minus 42x. Negative, positive, cancel, and minus 8. No, minus 10 x plus 15. Now we need how much? Minus 5, just minus 5. And minus 3 times minus 5 will be plus 15. Exactly, that means our previous solution, previous answer, a equal to 19, b equal to 15 is perfect. There is no mistake in it. Alright, now we have to factor this to completely. They said fully factorize. So we have to factor this quotient we got here. So I will use my factoring method for this. You can use quadratic formula or your calculators if you are comfortable with it. I like factoring method. So 3 times negative 5 is negative 15. Negative 15 I have to divide into two parts so that I get positive 14. So 14 plus and this is minus. So yeah, that's how here we'll get the factor. So 3x square plus 15x minus x minus 5, 3x x plus 5 plus negative 1 x plus 5. So factors are x plus 5 in both and 3x minus 1 from others. Final answer will be, we already had 2x minus 3 confirmed, it was given in the question itself, but now we got these two, x plus 5 and 3x minus 1. Done it. Okay. Question number 7. Write down the set of values of x for which log 5x minus 3 exists. So you should be aware that this is how any log graph looks like. It is never 0 or below. That means this 5x minus 3 has to be positive all the time, then only it will exist, right? And that's how we will make it an inequality and divide both sides by 5. That's our answer. X is greater than 3/5. Alright, next, solve the equation log of this. The first step in this should be that this log must go. So 5x minus 3 is equal to, when we remove log from one side, the other side becomes the exponent of whatever was the base here. So there is no base, that means whenever there is no base, it means it's 10. So it becomes 10 to the power 1. So 5x equal to 10 plus 3 divided by 5 divided by 5, x equal to 13 over 5. Next, it is given that this is this where y is greater than 0. Find an expression for y in terms of x. Whenever they give us log, and luckily all of them have same base except for this 4. Okay, so keep this 4 on one side and all of them have same base, we can combine them. So let me do that. Log base y x equal to, not equal to, we'll bring this one also, minus half log base y 64. This also will go to the left, becomes negative. Log base y 162 equal to, and this 4 remains where it is. I just moved these two logs. I cannot combine these three logs unless this half is taken care of. And how can I take it care of? I'll bring it and make it exponent of 64. So new look becomes log base y x minus log base y 64 to the power half minus log base y 162 equal to 4. Now I can combine them. These two are subtracting, that means they will divide inside log. Log base y remains log base y for all. X is positive here, so it becomes numerator. This is denominator, 64 to the power half, which is 8. This becomes denominator. This is 162, which is also denominator because it is negative, equal to 4. And now we will use the same fact we used here. Whenever we remove log, the right side became the power of 10. But here the base is given y. So we'll get this. X over 8 times 2 is 16, 49, 4, and 1296 equal to y to the power 4, right? Now, what are the question? Question is, find an expression for y in terms of x. That means this 4 must go. So to remove this 4, we will give it an exponent 1/4. We have to give same exponent to the other side. So 4 times 1/4 will be 1. That's how we got rid of 4. Y equal to x to the power 1/4 over 1296 to the power 1/4. So y equal to 4th root of x. That's how we can write 1 power 1/4, but we have a number for this. 1296 power 1/4 is just 6. This becomes y in terms of x. Okay, let's move on to the next one. Question number 8. What is that? Differentiate y equal to this with respect to x. So y equal to 2x e to the power 4x. Now you can see that 2x is multiplying e to the power 4x. Both have this variable x. That means we will use product rule. What is product rule? When u and v are multiplying and we have to differentiate, we differentiate u first, then add, and we differentiate v in the second one. The other one is untouched. That's what we will do here. So we differentiate 2x, but we do not touch e to the power 4x. In second, we do not touch 2x, but we will differentiate e to the power 4x. Differentiation of 2x is 2 e to the power 4x plus 2x e to the power 4x. Its differentiation will be e to the power 4x itself multiplied by the differentiation of the exponent. Differentiation of 4x is just 4. So we can take 2 common here, e to the power 4, this whole thing comes out. 2 e to the power 4x is common. Nothing is left in this one, so 1 plus 2 is out, this is out, so we'll be left with 4x. That's it. This is the differentiation of what question they have given. Okay, hence find x e to the power 4x dx. Okay, so let me rewrite what I just got, because they said hence means we have to take help of this one. So what will I do? I will use this one, not this, because here I have taken something common, here nothing is common and it matches something. Let me write here. This answer of this came out to be 2 e to the power 4x plus 2, no, not 2, this is 2, this is 4, 8 x e to the power 4x, right? And it is dy over dx, right? Now look, x e to the power 4x dx, x e to the power 4x and dx can multiply here. So let me rearrange again. Dy is equal to 2 e to the power 4x dx, this dx multiplies with this, as well as with the next one, 8x e to the power 4x dx. Now this question matches with this part, right? Now we know that if I integrate this and integrate this, it's allowed. We can integrate both sides. Integration of dy will be y, which is this. So it will be y equal to, I can integrate this one, 2 remains 2 untouched, e to the power 4x, but in integration we divide by the differentiation of the exponent. Here we multiplied, look here, we multiplied by 4, but in integration we divide, right? It is done. Plus 8 I am taking out and rest I am writing here because I don't know how to do this. But luckily this whole thing matches with our question. That means if I bring this here, y minus 2 and 4 cancel, half e to the power 4x is equal to 8x e to the power 4x dx, right? So now y is 2x e to the power 4x. In the question part A it was there, 2x e to the power 4x minus half e to the power 4x, and we have to get rid of this 8 also. There's no 8 in question, so let's divide this by 8 and multiply them by 1/8, the same thing. Whatever I did here I have to do the other side also. This 8 is gone. Our question is this now. That means I have to divide this by 8, divide this by 8 is equal to x e to the power 4x dx. 2 and 4 cancel, 1/4 x e to the power 4x minus 1 over 16 e to the power 4x. That's it. This is the answer. Only thing left here is to write plus c. Okay. Question number 9. Question number 9 says find the unit vector in the direction of 40i minus 9j. So 40i is positive, that means I is x direction. So that means this direction, this graph goes 40 units, and minus 9j means goes down 9 units. And this is the vector they are talking about, this one. This is the sum of the two, 40i minus 9j. What they are saying is that find a small unit vector, this one, in this direction. So what do we do in such case? That we find the magnitude of this, right? So whatever is the magnitude, we divide by the magnitude and we'll get the magnitude equal to 1 unit. That's what we do. So that means 1 over 40i minus 9j, its magnitude, we just multiply it with the vector itself. That's how we find smaller vector, right? We find the fraction of the big vector to get a smaller unit vector, and we have to find this one. So the magnitude of 40i minus 9j will be square root 40 square plus minus 9 square, 3 no not 3 6 1 6 0 0 plus 81 square root. So it becomes square root 1681, which is 41. So it will be 1 over 41 40i minus 9j. You can leave your answer like this, or if you want to bring 41 inside, you can write 40 over 41 I minus 9 over 41 j. This is the unit vector in direction of the vector they are saying. The position vector of points P and Q relative to origin are P and Q. Okay, the point R lies on the line PQ. Let's try to visualize this also. So this is P, this is Q, and point is somewhere here R. So PR over PQ is K. The ratio of P to PR to RQ, no, not PQ. PR and PQ, PR and PQ is K. That means this is K and this whole thing is 1. Yes, can I write K equal to K over 1? So if PR is K, in the ratio the whole PQ is 1. That means K will be less than 1. Write down all set of all possible values of K. Okay, in that case we will have to assume that it is between P and K, because they are saying lies on the line PQ. PQ, they didn't say line segment, but let's assume it is inside. In that case we can find. So it is possible, the smallest possible value for R is that it is very near to P. R can be here. So that K is very small, almost 0, but not 0. It can't be 0, right? So we can say that K is between 0 and 1. Why 1? Because R can be the whole length PQ, little less than that. Not completely 1, but almost equal to that. So R can have a position from here till here. That is the range it can have. What about the second one? Given that the position vector R is relative to O is lambda P plus mu Q, show that lambda plus mu is equal to 1. And this is the position vector, right? This one. So look, suppose O is here. It is always with respect to origin, correct? So this vector OP, let's write here, OP is P. Similarly, the vector from O to Q is OQ, which is Q, right? Now OR, suppose it is here, and they're saying that given that the position vector of R relative to this is lambda P plus mu Q. All right, can we somehow relate the two, right? Let me relate this one, OR. Can I say that OR, vector OR is equal to, I'm not going to O to R straightforwardly, I'm going to P first. So OP plus PR. Yeah, this is PR. So OP to PR, we get OR again. So we can write that OR is OP plus PR. PR is from here, from this P to this R. This is PR, right? So can I write PR equal to K times PQ? It is K factor of the whole length PQ. And PQ can be written as, let me write PR equal to K times PQ will be, because head is at Q, so OQ minus OP, right? And OQ is Q and OP is P. So we can write K Q minus P. Here we can write K Q minus P. Similarly, we can write OR is equal to OQ plus QR, right? So OR is OQ is Q plus, now this time QR is to be written like this. So QR can be written as 1 minus K. Yes, because this factor, let me change the color, this one, K has been removed from this, so this part, this fraction will be 1 minus K, QP, isn't it? So it becomes 1 minus K times OP minus OQ. So it becomes 1 minus K, OP is P minus Q. So it comes here 1 minus K, P minus Q. OR has been expressed in terms of this and this. Let's add this equation number 1 and equation number 2. Let's add them. So OR plus OR will give you 2 OR, correct? This OR plus this OR will be equal to P plus KQ minus KP from this side, and here it will be plus Q plus P, and then 1 times minus Q is minus Q, then minus KP plus KQ. Now P plus P is 2P. 2OR equal to, okay? Alright, P plus P is 2P, KQ and plus KQ is 2KQ. KP minus KP minus 2KP. Then we have Q and Q cancel out here, right? Anything else? Everything has been taken care of. So we can see that all of them are 2. So we can write that OR, divide all of them by 2, okay? OR is P plus KQ minus 2KP. OR is given to us mu P plus, sorry, not maybe lambda P plus mu Q is OR equal to P plus KQ minus KP. This 2 is gone. Alright, can we compare P's now? So lambda P plus mu Q equal to P and P, there are 2 here, 1 minus K P plus KQ, right? So we can say that lambda is 1 minus K. From here, comparing the two, we can say that lambda is 1 minus k. Mu is k. And if we add, we want to show that lambda plus mu is 1. So we can add lambda plus mu will be 1 minus k plus k. And they cancel out. We got lambda plus mu is equal to 1. In such question, we should be aware of our target and accordingly we should proceed. That's how I did it and reached where we wanted to reach. Okay, let's move on to question number 10. They have given a diagram which shows the part of the curve, and this is a quadratic curve opening down obviously because the leading coefficient is negative. Okay, the point A lies on the curve. Okay, this is here and has a x coordinate of 1.5. So that means this is 1.5 and x coordinate is 1.5. Okay, y coordinate may be needed later. The tangent to the curve at A meets the x-axis at B. Okay, here the curve meets x-axis at C. Yes, find the area of the shaded region. How about this? I find the area of this triangle. That's my plan. I find the area of this triangle because finding the area is very easy. Half base times height. Then what I'll do, I'll find the area under this curve from 1.5 till C, this one, and remove from the area of the triangle and we'll get the shaded area. That is the plan. That's what I'm going to do now. For finding the area of the triangle, let's write here, area of the triangle will be half base times height. Do we know the base? No. For knowing the base, we should know the coordinates of B, right? It is worth 10 marks, keep in mind. That means find the coordinates of B and we get the base. What about height? Yes, we can find the height because this point has x coordinate on A, which is on curve. So if I substitute x equal to 1.5 here, I'll get the y coordinate. That will become the height of the triangle. Let's do that one first. So when x is 1.5, y is 3 plus 2 times 1.5 minus 1.5 square, which will be 3 plus 3 minus 2.25, 6 minus 2.25 will be 3.75. So the y coordinate and the height of the triangle is 3.75. Now challenge is to find the coordinates of B. B is found by finding the tangent's equation and its x-intercept will give us B. So we have to find the equation of tangent first. Equation of any line is y minus y1 equal to m x minus x1. We used it in one of the previous questions as well. We know x1 and y1, we know these are x1 and y1 because they are lying on the tangent and on the curve. Only challenge here is to find m. M is nothing but dy dx at x equal to 1.5. So let's find dy over dx of this equation. So dy over dx for the curve will be, differentiation of 3 is 0, don't touch it. Differentiation of 2x is 2 minus differentiation of x square will be 2x. 2 minus 2x is, so m becomes 2 minus 2 times x is 1.5, 2 minus 3 which is negative 1. Doesn't look like negative 1, but these drawings are not to the scale in y direction may be different. So negative 1, but yeah, it is going down, it's negative. So we know m, we know x1, y1, we can find the equation of the tangent now. Let me write it here. Y minus y1 is 3.75 equal to m is negative 1, x minus x1 is 1.5. But I don't want to simplify this because my purpose is to find the coordinate x coordinate, that is of b, when y is 0. So let's put y equal to 0 so that we get the x coordinate equal to negative x is x unknown minus 1.5. So this particular negative sign we cancel out. So 3.75 and this negative 1.5 will come with here, becomes x, which is 5.25. So the coordinate here is 5.25, and now we know the base of this triangle. We can find the area now. Half base will be 5.25 minus 1.5, right? We have to subtract till here, not the whole. Multiply by height. We found height earlier, which was 3.75. So, okay, half 3.75 again. So height and base are exactly same, which is equal to 7.03125. Let's stay here, 7.03. Okay, units square. Now we have to find the area under this curve from 1.5 till C. We don't know the coordinates of C as well, but we can find it because we know the equation of the curve. Just put y equal to 0 there. So 0 equal to 3 plus 2x minus x square. So you can use your calculator for this, and I'm using factoring method. So 3 plus 3x minus x square, 1 plus x minus x 1 plus x. So it gets 3 minus x and 1 plus x. So this gives me x equal to 3. If I make it 0, this equal to x equal to minus 1. This one doesn't make sense because x equal to minus 1 will be on the left side. So this is x is equal to 3. So now we know that we have to find this area from 1.5 till 3. And that's what we're going to do now by integrating this particular curve, but not from 0, 1.5 till 3, and we have to integrate 3 plus 2x minus x squared. That's how we find the area under curve, right? This area we will get here, we will subtract from 7.03. So we get here 3x plus 2x squared over 2 minus x cube over 3 plus c 1.5, 3. Let's substitute 3 and 1.5. 3 times 3, 9. 2 and 2 cancel. Plus 3 square is 9 minus 3 cube is 27. 27 divided by 3 is 9 plus c minus 3 times 1.5 will be 4.5 plus to 1.5 square 2.25, then 1.5 cube, which is 27 over 8 divided by 3, 27 over 24. 27 over 24 plus c. This c and this c cancel out, and thus we get 9 and 9 cancel. 9 minus 4, and this will be 6.75 plus 27 over 24, which is 3.375. Now shaded area we want to find will be 7.0325 we got earlier minus 3.375 now. Let's say 7.0325. It is 3.657, so 66 we can say. 3.66 units square. This is the area of the shaded part finally. Let's go on to the next one, which is this. The sum of first 20 terms of an arithmetic progression is 1100. The sum of first 70 terms is this. Find the 12th term. Okay. To find the 12th term, that means A12, which will be A plus 11D, right? That means we should know A and D, and these two facts which have been given will help us to find A and D. The formula for sum of n terms is n over 2, 2A plus n minus 1D, right? And this is what we will use here. So for sum of first 20 terms, so S20 is 1100, which is 20 divided by 2, 2A plus 20 minus 1, 19D, 10. Let's make it simple by dividing by 10 here and dividing by 10 here. So that this 10 also goes. So we are left to 110 equal to 2A plus 19D. That's equation number 1. Let's find the second one. First 70 terms is 14350 is 70 divided by 2, 2A plus 70 minus 1, 69D. Alright, so let's multiply. This time let's do cross multiply, okay? So 14350 times 2 divided by 70 equal to 2A plus 69D. 0 and 0 cancel, and 1435 times 2 divided by 7 will be 410. 2A plus 69D. And now we can subtract this equation number 1 from this equation number 2. 110 equal to 2A plus 19D subtract. 410 minus 110 is 300. 2A and 2A cancel. 50D. Divide both sides by 50. So D is equal to 6. We got D equal to 6. We can find A by using this one. 110 equal to 2 times A plus 19 times 6, which is 114. So 110 minus 114 equal to 2A minus 4 equal to 2A. So A is negative 2. We got A and D both. Question was to find 12th term, and now we can find 12th term by using this one. A12 equal to A minus 2 plus 11 times this, which is minus 2 plus 66. 64 is A12. Okay. Part B. The first three terms of a GP are these. Show that x satisfies the equation this. That means we have to convert it into this. Hence show the sum to infinity exists for each possible value of x. Let's focus on this one. The sum to infinity exists means it exists. Sum to infinity exists for r is less than 1. Any r which is less than 1, we can get sum to infinity. So if both the answers are less than 1, we get it. So let's continue. First, we should know that A1 is x plus 6, A2 is x minus 9, and A3 is half x plus 1. we know that R common ratio will be A2 divided by A1. Also A3 divided by A2. Every term divided by the previous term is always R, and that's what we're going to use. A2 x minus 9 over A1 x plus 6 equal to half x plus 1 divided by A2 x minus 9. It will multiply with the denominator 2, and now we can cross multiply this and this. So 2 times x minus 9 square equal to x plus 1 x plus 6. A minus b square I will use here. A square plus b square minus 2 ab, and here I will individually multiply them. X times x is x square, x times 6, x times 1 times x, and 1 times 6. So we get here 2x square plus, this is 81 times 2, 162. 2 times 9 is 18. 18 times 2 is 36x equal to x square plus 7x plus 6. They want this. So let's bring everything to the left side. 2x square minus x square, this one, minus 36x plus will become minus 7x, this one, then 162 minus 6 equal to 0. Nothing is left on the right side. 2x square minus x square is x square minus 43x plus 156 equal to 0. This is what was the requirement. Show that x satisfies this equation. We have shown it. Now they're saying that show that the sum to infinity exists. In other words, both r's, this quadratic will give us x, correct? Both there will be x values which will give us r less than 1. So let's simplify this one. So 156, 39 times 4. So x square, I'm factoring this, okay? You guys can use your calculator, you are free to use it. X minus 39 minus 4, x minus 39. So x minus 4, x minus 39. This will give x equal to 4. This gives x equal to 39. Now let's see if they give us r, which is less than 1. So when x is equal to 4, I'll take this one, which is this. X minus 9 over x plus 6. This is r. X is 4. 4 minus 9 over 4 plus 6 is how much? Minus 5 over 10. Negative 1 over 2. Less than 1 or greater than negative 1. Okay. X equal to 39. 39 minus 9 over 39 plus 6. That is 30 over 45. 2, 3. Again. So since r is between minus 1 and 1, r is not equal to 0, sum to infinity exists. Alright, what about last question number 12? In this question, all lengths are in centimeters. A container of half cylindrical open shape. It has length y, uniform cross section, x radius. The volume of container is this. Given that x and y can vary and the outer surface area S of the container has minimum value, find this value. This is basically they're asking you to optimize, find the minimum surface area. Yeah. So first we'll take the help of this 25,000 volume. So volume of half cylinder. will be half of pi r square h, right? And it is given as 25,000. 25,000 is equal to half pi, r is x, h is y. So we want the minimum surface area, and let's isolate y in such case. So 2 will go and multiply here, 50,000 divided by pi and x square will become denominator. And now we have to find the surface area. Surface area of this, and they have shaded the surface area, that means outer only, not inner, as containers minimum value. Outer surface area they have written here. Okay, so the surface area of full cylinder is pi 2 pi r plus h. But since this is half of that cylinder, nothing additional, nothing less, just cut in half, so we'll divide it by 2. This is the one. In this case, r is x, so we will write pi x, x plus y, right? So let me use the alphabet A for this. So A becomes pi x, x plus 50,000 in place of y. I'm writing this as 50,000 over pi x square. Okay, so it becomes pi x square plus 50,000 over pi x square multiplied by pi x. Pi and pi cancel, and 1x cancels with this one. So finally A comes out to be pi x square plus 50,000 over x square. No, just x square, this 2 was cancelled out. Now to find minimum surface area, first we should find the rate at which the area will change, dA over dx, and this differentiation will be 2x, so 2 pi x. Pi is a constant, so we don't touch it. 50,000 is also a constant, don't touch it. Just 1 over x. Let me differentiate here. How do we do 1 over x? Can we write 1 over x as x to the power minus 1? And when we differentiate, minus 1 comes in front, so minus 1, and this exponent goes down by 1, so it becomes minus 2. So basically it becomes 2 pi x minus 50,000 over x square. Over x square, because it's a negative, I made it denominator. Now for maximum or minimum surface area, dA over dx has to be equal to 0. Stationary point we have to find. We'll make it equal to 0. So 2 pi x minus 50,000 x square is equal to 0. Let's write 2 pi x equal to 50,000 over x square. We want to find x, for which we'll get minimum or maximum surface area. So multiplies here, x multiplied by x square is x cube. Take this 2 pi here, cross multiply, 50,000 over 2 pi. Since it's a cube and it's positive, that means we'll get only one value, which will be cube root of these. So cube root and cube cancel out. We get x equal to cube root of 50,000 over 2 pi. Let me use my calculator for this. By the time I do this, I would request you to subscribe to my channel. This is the last question and last answer for this exam. If you liked it, like the video also, subscribe to my channel, share this with your friends so that all of you get benefited, and I'm motivated to make many more videos like this for you. What I'm getting here is 19.964. this is x, but we have to find minimum area, minimum value of area, and that's what we're going to find now. So area was this one in terms of x, pi 19.964 square plus 50,000 divided by 19.964. It comes out to be 3756.625. Rounding off to 3 significant figures will be 3760 centimeter square.